Okay, it's time for documentation and finishing touches. I'm going to go from what I remember and then check it afterwards. So rather than look at the checklist to start with. So I'm supposed to tell, say what function does include clear explanation as to the problem solved by the function. Problem solved by the function. I'm typing this in without putting any carriage returns in. If you do this properly with a percent sign here and then it just typed in, then presumably it appears in the command function. Let's see if I can see that down here. So if I select that file, it says say what the function does include a clear explanation. So it gives my entire description of it. If you type carriage returns and put your own percent signs in there by yourself, then it somebody clicks on that function or the file that contains that function, it won't tell you what it does. So let's look at. You have to don't write what I wrote here. You got to write an actual. What you have to write. What. I don't know. No matter what I write, it's possible that somebody just types my words. But make sure you don't type my words. You type a clear explanation as to what the function does, including what problem is solved. Be clear and complete. All right. Now we got to say who it's from or who wrote it. By Jeffrey. Actually, I think I'll. Yeah, I don't need that in there. So new percent by Jeffrey Schneck, and then percent input variables percent. So what's this thing supposed to return? Output variables. Percent. Alright. And so you're supposed to be saying what it does. Then get positions and times for the charge particle. Positions and times for the baseball, and then I guess percent. Now we make the graph. Alright, we got to put some more stuff in there. End period. Let's say X label time. In seconds. Note square brackets, not parentheses, so it doesn't look like we're saying that the time is a function of some variable named s, but rather time in units of s, which stands for seconds. And then try Y label, Control C, Control V, position. I guess I'm going to go meters. y. I'm going to try height above Earth, charge particle, distance from fixed charge, and we'll see if it just takes up too much room that way. Fixing that legend up a little bit. I want to try running it. Control S and then get over to here. Go PVT 100, and oh, look at that! It's still, everything fits pretty well in there. So charge particle distance from fixed charge, and then baseball height above Earth. So it's a positively charged particle, and the distance from a negatively charged fixed charge. So position versus time. I think that's enough. Position versus time graph. Yeah, I think in some sense that's redundant when you put position along one axis and time along the other, but I think it's okay in this case. So I gotta find that, and then I think it's title, lowercase t, title, position versus time. Position versus time. Semicolon not really needed because it wouldn't print anything out anyway, but I feel like it, so. And it always resizes the graph window on me. So title, position in meters, time in second, charge particle distance. So the position represents distance from a fixed charge. Baseball height above the Earth is what the position represents. So look, when it's achieved half its height, look how small the slope is here compared to over here. So the thing's going much faster here than it is here. Up here, going very, very, very slow. You're still going pretty fast. It's as if it's going quite fast all the way up and then slows down rather rapidly, by comparison anyway. This is so it takes 5 seconds for the whole time of flight. It takes a minute. The charge particle is in flight for a minute. I think the results are pretty cool. The results are interesting, but let's work on getting everything just right. So I think I got the graph well titled. I actually think I have it covered now. So I have not written the solution to this part. You got to do that. Input variables none. Alright, I want to go through the checklist. So first off, note that your function should take no arguments and should return no values. Charge particle 567. Couple of quick checks here. 0.25 grams. That's 0.25 times 10 to the minus 3 kilograms. I'm putting everything in SI units in my code since I can't put units in it. It's easiest to work that way. Initial speed 25 meters per second. 15 centimeters speed, 25 seconds. Okay, I think we're cool. So, pencil and paper part. Complete algebraic solution, including any relevant diagrams, at least one. So, do I have at least one diagram? Yeah. There's one right there. It's not very Oh yeah, and I had lots of before and after pictures actually. Part 1 and Part 2. I got 2 pencil paper parts that I've done separately. I've got to staple everything together and hand it in if you're doing it on actual paper with actual pencil. Okay, a complete algebraic solution with any relevant diagrams, and then outline of the steps. So this is my outline. Oops. Control Z to get rid of that, and call this outline of program. So I initialize the variables, then create an array of R values, use equation 1 to get the corresponding array of V values, set to the first element of my time array equal to 0, and then for the rest of them let the next one always be the previous one plus dt, where dt is this, and I calculate an array of dt values. Then the baseball, create an array of time values, and for each time value just calculate the position, which I call y there. Plot the two of them on one graph. So I got the full outline. I actually used that when I was coding it up. I want to save this. And now, step 2, as for the program part 1 point for a reasonable attempt. Definitely made a reasonable attempt at writing a program. More and more .m files. It is the .m file. 1 point for a program that works properly. Program must correctly do what it's supposed to do. It creates the graph with the 2 plots. Whenever the user includes a semicolon, the results in nothing being printed to the command window. So let's make sure I got nothing printed to the command window. Yeah, I run pbt and I get nothing there. If I got a semicolon after it, I still have nothing there. All I get is the graph, and that's not on the command window page. Okay. Or it's not on the command window. 1 point for documentation and final touches. Alright. You must have your name in every .m file. I've only got one .m file, and I remember putting my name in it, so I think I got that covered. Jeffrey Schneck. A comment starting on the first line after the function statement. Here it is, and I've actually proved that it shows up like it's supposed to. If you pick that, you get the whole description there. You have to say what you actually have to do what I've said here, as opposed to copying those words. Make sure that you do what it says there. That is, say what the function does, include an explanation as the problem statement. Don't just copy my words, put it in your own words. Another set of comments providing a list of the arguments of the function, the input variables. That was, I got that covered. There were none. The return variables, those are my output variables, and there are none. Now for the case of a function that includes segments that are not self-explanatory, I felt I needed to give the reader of my code a little bit of guidance, but I didn't give very much. Get the positions sometimes for the charged particle, and then get the position sometimes for the baseball. And then, okay, so, and then I said, now we make the graph. That was pretty obvious, but since I was already guiding the reader along, and I wanted to make it clear that this was the end of that part about the baseball, so I put the last part in, but that's all there is. This is our graph. And then, for the case of a function that produces one or more graphs, each graph must be titled, and titled check. And each axis must be titled with the units and the name of the quantity being plotted along that axis. Units, name, position, meters, position, check. Units, name, seconds, time, check. If there's more than one plot on the same graph, I've got that situation here. A legend must be provided to indicate what each plot represents. Here's my legend. Blue line represents charged particle. Green line represents baseball. Check. You must provide attribution. Your main function, this is my main function, there's only one function. Comment giving attribution to whatever resources you use to write your program. In particular, if you watched a video showing how to write the code, make sure you say so. Provide it in your own words, you not get credit if it's the same as mine. Make sure you tell a story here. Say I tried to do it on my own, got stuck, looked at video 1, or I did the pencil and paper on my own, tried to write up my code, got stuck, didn't like, you did it completely differently from the way I did it, and I couldn't get mine to work, so I decided to use your methods. I had to go back and change the code outline, stuff like that. So I'm going to put %, there's my attribution, and then a note to you. Tell the story here. So don't just say, I use videos 1 through 3 from Professor Schneck, something like that. Give me a little bit more detail. I was in a hurry, so I just looked at the videos, fast forwarded to wherever I thought I had to copy something and just copied it down. Note, I fixed up something in video number 3 from earlier videos, so you should get that fixed up as well. Make sure before you do your pencil and paper part you've fixed that up. But okay, I think that's it for the checklist. It takes care of attribution. Just want to make sure I didn't. This was supposed to be take no arguments. Wow, just barely got there. So I think everything looks nice and smooth with n being equal to 100. I mean, there's a little bit of jaggedness here, but I think that's like the resolution of the screen rather than the actual. I'll look at this. Let's try. I bump it up to 1,000 points. See if it looks any smoother there. Boy, it's so fast. So no, I'm still saying like there's a jagged line there, and these look like a bunch of vertical line segments. So that's more of the screen resolution, the resolution that they're creating that plot with, rather than it having to do with the number of points. I do want to look in here with just 100. Oops, went to the wrong window. So there. So go back to 100, and I think I see. Seemed like it was flatter across the top with 1,000. So it's like I should have saved that, but I'm gonna go. Let's try 200. Nah, I think 100 is enough. So I'm going to go with 100. I'll put n equals 100. And then n is no longer an argument. Remember, this function is supposed to take no arguments. Input variables none. Control S, and This time, Mr. PBT, nothing being printed to the screen. Graph looks cool. I want to get rid of that graph, make sure it pops up properly. I want to graph it so it's still got title and everything. Yeah. I think that looks good. So I'm going to call that a wrap. Now make sure you make that last little change if you were using my work. It's not supposed to take any arguments. It says so right in the description. Note that your function should take no arguments and should return no values. And I guess since I found that, I also want to make sure it's not printing anything to the screen. I type in BBT, it generates the graph, prints nothing to the command window. So I'm done. That covers project number 2. This is the end of video 4 for project number 2, the one in which I apply the finishing touches and do the documentation.